Max Silverman, I'm part of the Microsoft Developer Experience team, and I'm responsible for the native implementation of the WebRTC library.
Perfect, and then lower left.
Robin Raymond. I've been working on the ORTC lib and been also integrating with the Microsoft people in making sure that it works with their technologies as well.
And then middle lower section.
Hi, my name is Shijun Sun. I'm working in the Microsoft Edge team and in the RTC area.
I'm Bernard Aboba, architect in Skype, so work on Skype applications running on multiple browsers, as well as helping out the Edge team on the implementation of WebRTC and ORTC.
Perfect. Good to have all of you remotely. And then Anthony.
I'm Anthony Manasali, the developer of FreeSwitch, and we're kind of a unique implementation of WebRTC from a server standpoint.
Seven.
Hello, I'm Seven Du. I write most of the video code in FreeSwitch, and the codec, everything. Thanks.
My name's Travis Cross. I'll be moderating the panel, and if you'll hand me that one.
I'm Randall Jessup from Mozilla, and I'm the module owner at Mozilla for WebRTC.
I'm Philip Hankey. I work for Aperion, a video chat service, and I found about 5% of the external WebRTC bugs for Chrome.
And hi, I'm Chad Hart, editor at WebRTC Hacks, a blog for WebRTC developers, and I also do WebRTC stuff at Voxbone.
Anthony, let's start with you. And you could talk about the state of WebRTC and FreeSwitch and sort of what you've been seeing in terms of WebRTC trends and where things have been going.
Well, WebRTC and FreeSwitch has been a bumpy ride, as it's been for everyone, because we're just figuring this out. We started out with just audio. We expanded to video. In the last 1 year, we've been solidifying that. As you can see here, we're using FreeSwitch right now to bring our remote guests in. This is an implementation of our MCU, which is kind of unique because a lot of the WebRTC applications right now are focused more on the SFU model, but FreeSwitch lends itself more to an MCU. So we decided to leverage that functionality. It allows us to do cool things like change the layout anytime we want, and put banners on top of people's video and that kind of stuff. So I would say that since January, when the standard was finalized, there's been a few efforts to bring everything to match those standards, which is hard to keep up with when we're, a lot of people are doing work on the browser, so it's kind of like a cut and dry, like implement this API to work the way the spec says. But from us, it's like we have an actual WebRTC media engine, which is a little more work than a lot of other apps have to do. So we're interfacing with the browser directly, and it's fun to find all the problems with that. It's like an ongoing thing.
Well, Anthony, why don't you say a few words about what we're seeing right now? I mean, you do have the crowd may not understand what we're viewing at the moment.
Yeah. So if you guys are paying attention to Windows and the release cycle, the Windows 10 anniversary update was just released less than a week ago. Basically, as soon as that was made available, we jumped on it and spent the last week doing some interop. And what you have up here now is a Microsoft Edge browser doing audio and video. All these people here are using it as their client, and this computer up here being run in the back is running on Microsoft Edge, which when we were here last year, we were talking about how you could make the camera mirror your face on the screen, and that was basically all it could do. So in 1 year, we managed to go from that to pretty much matching what all the other browsers can do, which will just be more, help solidify things. So yeah, you should give those guys a hand for developing all this stuff so quickly. It's not that easy just to pull it up.
Robin, are you in via Edge or Chrome?
I'm in via Chrome at the moment. So that's why
Yeah, so
probably
we have,
my video isn't
so we
quite as
have-
good as the H.264.
but we have interoperation with Firefox and Chrome as well. If you come in with Firefox, you'll also see us.
Yes, and all the above can use, well, I think Edge right now can do H.264, right? And so you have
Yeah.
codec transcoding happening here too, where probably the codec order in FreeSwitch right now is VP8 and then H.264. So if you call on Chrome, you're going to end up on VP8, and you call in on Edge, you're going to get H.264. And Firefox can do both. So it's still probably going to prefer the VP8 because of our codec order, but you could purposely choose to use H.264 on Chrome and Firefox as well. But the way it's working right now, it's probably transcoding between both, depending on which one you pick. And that's something you can just do in FreeSwitch. So we have codec negotiation preferences. You can set them in the order you want. And we've just been defaulting to VP8 and then H.264 because that's kind of the way things have been for a while. So yeah, you've got browser interoperability, kind of like I demoed a minute ago, but now we're using it for practical use. So hats off to the Edge team for getting WebRTC implemented and actually usable in such a short time frame.
So I know there have been some ups and downs with WebRTC and FreeSwitch. What are some of the recent challenges that we've hit, and how are we able to find solutions to them?
The most recent challenge was probably from our perspective, we're really implementing things as we learn about them. We don't necessarily have direct access to like the latest changes from the browser point of view. So when we started making our WebRTC virtual library, we did not have the adapter.js kind of matured to the level it is now, so we didn't use it. And with the changes now, the simplest first move was to probably jump to that. There's a lot of changes in the structure of just the API and the JavaScript and whatnot, and the adapter.js shields us from that, which we can hear more about from Philip. That's kind of his baby there, and that gives us kind of a buffer to spare time. So when we use that, at least when something changes, we won't even notice. And then it gives us the ability to code to the standard, you know, and wait for things to happen. Like right now we're using, I gave a demonstration of Safari actually working. That's using a plugin, and that plugin is temporary. Because if WebKit started working on doing WebRTC also, so once that happens, you can pull that plugin out, and adapter.js will just cover it. And it gives us time to not have to worry about changing stuff all the time. We can just focus on the outside of the application. And then once it's kind of old and stable, we'll probably go and do a bunch of refactoring and pull out some of those normal, because that's always a problem with JavaScript since the dawn of time is too many layers. So right now we have 2 or 3, and we might probably cut it down to 2, maybe even 1 over time. But now there's not a rush, which is good.
Philip, do you want to talk a little bit about that layer, what it does, and how it helps out here?
Right, so adapter.js is a shim layer for WebRTC. It was started by Google back in 2012, and it basically abstracts the fact that the browser still, or well, Chrome still doesn't implement the RTC peer connection APIs. They still have prefixed it as WebKit RTC peer connection. Mozilla originally did a MOS RTC peer connection, and recently, about 6 months, a year ago, they changed that to the spec style. And if you're writing an application, you need to deal with those changes in the browsers. And adapter.js does this job for you. It just hides those things from you, and it allows you to write code that is compliant to the WebRTC specification. And there have been a lot of changes in the spec recently. For example, the spec has moved to using promises instead of callbacks, and that has been implemented in Firefox for quite a while. Chrome took more than 1.5 years to catch up on this, and they only recently added native support for promises. At the same time, you couldn't just write code that uses promises, which is really much more elegant, a better way to do this JavaScript stuff.
And in addition, it also converts things like the constraints for get user media and lots of other detail things where one browser or another is not up to the spec. It tries to cover over those differences and does a pretty good job of it.
Do you want to talk a little bit more about some of the interesting things you've been doing here and what you see going forward?
Yeah, there's been a lot of work going forward here. We've just landed a whole bunch of work for constraints and for also doing things like get settings on get user media streams, so you can modify the constraints on the fly, find out what constraints are in use. We're working on simulcast support, so you can send multiple resolutions at the same time. That's landed in the code. No one's really been using it yet, but we're starting to work on getting that tested and work on interop with various people. We'll be working with the Edge people on that. Oh boy, there's a lot of stuff we've been doing. We're trying very hard to follow the spec as much as we can. We've been trying to lead on spec compliance quite a bit. Like with the promises stuff and the get user media constraints. And we hope everyone else will be following along, and so we can reduce the need for as much code in adapter.js. We like to get a lot of feedback from developers, so we're looking for anything you guys can feed back to us about what's working, what's not working, what you need. I was poking Fippo here for that, and also Emil. We're always available on IRC, on Mosnet in irc.mozilla.org in Pound Media. So if you have a question, come on in, ask. Usually there's someone around who will answer it. So
He's serious about being always available. He's on IRC right now, right this very minute.
yes.
So if you have a question, you could pull it up to him. Let's go to the video here. Max, what are your thoughts about where things are going and some of the interesting things you've been working on?
I agree with oh, there's echo. I agree with the rest of the panel. I think we're moving very fast, and with the finalization of the spec nearing, it's there's wide interest in both web and from web and app developers.
Okay, Robin, what are your thoughts on it?
Well, I've been concentrating on more the mobile end of things with the ORTC lib. There's a lot happening in the specification area. I'm glad to see WebRTC and WebRTC NV and the ORTC community groups kind of come together as a unified specification, and I'm looking forward to what the future is going to bring. So, and being concentrated on the mobile space and the particular issues in that area, I'm glad to see what that's going to bring when it's incorporated in a free switch. So you're going to have this, newer model and more traditional model working together. So I'm really excited what's going to happen there in the future too, and hope to get some opportunities to work with the free switch guys to prove interop there in the future as well.
Well, maybe for our audience here, you could talk a little bit about what has been going on in the mobile space with WebRTC and where that stands and kind of where you see that in the next 6 to 12 months.
Sure. I think the biggest area of problems in the mobile has to do with ICE-related issues, and it's good to see that they're doing a lot of work in the different IETF groups regarding mobile ICE and the mobile ICE issues, specifically that in traditional WebRTC desktop, your ICE negotiation completes and you're done and you're stable and you're in a stable state. You're connecting between two peers on a desktop and you got a stable IP address. With mobile, that's not true. You can be walking away from your Wi-Fi hotspot, switching over to 4G LTE, and then come back and your IP address changes and your firewall situation changes. You're going into a corporate network. So you're constantly dealing with changing IP addresses. And so you can't complete ICE. And that's one area that I'm seeing as a really important future step. And there needs to be also some surface changes to the WebRTC specification to be able to support those scenarios. It's not a big deal in terms of the API change, but it is a big deal in the user perspective when they don't see their call drop and it just magically works.
I work in the mobile space as well, and one of the interesting problems there is actually providing feedback to the user when things fail to tell them what they can do and what they can change. Do you see any of that getting into the standard about how we can help communicate up to the application layer what's actually going on and what's failing?
Well, there's several aspects to that. One is just getting the statistics to give you the correct information, the application developer, and then the application developer being able to understand what those statistics mean in the first place. And I think there's a lot that we can do to prevent the failure in the first place, in terms of making sure to keep multiple paths available for your ICE scenario and preventing the issue. And then, but ultimately, there's only so much you can do. If you're walking in a dead zone between a hotspot Wi-Fi and then going to LTE and you're not quite ready yet, then you really have to inform the user saying, hey, something's going wrong. And I don't believe that we've got the complete surface API point to be able to inform the user properly about those situations, even in an ORTC spec. So I do think that there's room for improvement even there. So the only way we're going to get there is to get the real world user feedback when they're using these applications and say, hey, this application isn't working very well, what's going wrong? And then we can feed that ultimately back into the specification and have the API surface points to be able to have good user feedback ultimately. So it's still a work in progress and we've got a ways to go, but it's going to get there, I think.
Is anyone else on our panel here focused on the mobile side? Anyone in the video? Does anyone in our audience work on mobile and have questions about the mobile side while we're... Okay, you have a question? Do you have a question back there or just up front? Okay, could we get a mic down to him? Okay. Right there.
So if I need to implement a VoIP stack in my app, in my mobile app, Android, iOS, Windows, in the next couple of quarters, that will communicate to FreeSwitch, not to browsers, but to FreeSwitch. Should I just use the regular SIP stack or wait for WebRTC to be available? And if the latter, what would be the advantage of WebRTC from a mobile app versus regular SIP? SIP with SRTP, TLS, all of that.
Yeah, I can actually take that question. So we're making available within the next few days, we're making available a universal Windows platform, which is also short for UWP. We're making available a native component that you can use within your voice over IP applications on Windows 10. So you can use that on the mobile and on the desktop. It's the same app. The APIs that we did a lot of curation of Google Source, and we replaced both the audio and the video rendering on the Windows 10. So if you use the stack, you don't have to rely on the browser. You can also do this in multiple ways. One is you could take your existing JavaScript code and run using a technology we call WinJS, which can take your web HTML and web implementation and run it directly in the native container. So you're not running in the browser, but you are writing as a native app, reusing it. Or you could go directly and use XAML C# or XAML in C++.
I would actually like to expand on that question because I think there's some key issues here, if you guys don't mind, regarding the mobile space and this particular issue and what you should use. I'm not a big fan of putting SIP into an endpoint on the mobile space because of all the problems that you're going to run into. I think you got a lot more control when you use direct, and I think ultimately when you go to RTC, you'll even have more control. But even just using WebRTC today, you got a lot more control over what's going on. And I think that's really important when you're dealing with mobile issues. And I think that you're going to find being able to just be able to do your SIP on the back end, but have WebRTC on the front end, and being able to do your own custom protocol for all the different scenarios that you're doing on the front end will get you a lot further ahead and a much better user experience from what I've seen. And I think that the Windows team has a great advantage in that you can develop your applications using C# and cover all your Windows platforms all at once. And then you can use something like Xamarin to be able to build your applications continuing to use C# and develop for the other platforms as well. So I think that those are great technologies to use if you're trying to build native apps, but there are a lot of alternatives, including using embedded browser and using some kind of JavaScript wrapper there too.
One of the challenges with mobile is that increasingly as Apple and Google have pushed forward on power management, we're forced into a model where apps can't be running almost ever. And so the apps have to work in a model where they're not running, then they get a push notification, then they connect to the server, and then things happen. And SIP very much relies on this model of registering and then holding open this connection if it's TCP, or expecting to be able to get a reverse connection if you're doing UDP or anything else. And so SIP is you have to be very careful using something like SIP in mobile because it breaks every time Apple takes another step forward on killing apps more frequently, or Google decides to put things into DOS mode and break your connections. And so you really have to be thinking about not just the protocol, but how does the protocol interact with the push models that are used by the mobile platforms and by the life cycle of the applications. And that's where the hard part is in mobile, in addition to what Max mentioned there about, where's it Robin? What Robin mentioned about ICE and going through crazy networks and all of those issues. So it's quite a lot to think about. Anthony, do you have any thoughts since this question related to how he could tie it into FreeSwitch?
Yeah, there's I guess it depends. I have the feeling you're probably looking for some universal solution. Platform, like every kind of mobile at once, or? Because I think it's hard to find something that works everywhere. I know that the WebRTC.org engine that's basically used by all the browsers does work in most of the mobile platforms as well. There's React Native, where you can basically design it like a web app and have it compiled into something that you can execute. We hope one day maybe we can extend some of our Verto functionality, like right to mobile. It's a lot to bite off on top of what we're already doing, so maybe once we get everything under control, we could start exploring that. But we haven't dug too much into mobile stuff as far as our team, because we're always so busy working on FreeSwitch itself. But we've had an ancillary contact with some that were doing it, and I mean, it's been proven already. Like iOS, for instance, you can do. The browsers can't do it. Well, I think they can now, right? Were you just saying that? Somebody was saying that it's possible. But the WebRTC.org code is available to, you can build basically, you could take a SIP stack, for instance, and mix it with the WebRTC engine for media. You're just basically using the SIP to get the call set up, but you're still using it. Like there's been a few people who have proven that's possible. But then you've got all of those things that Travis was just talking about, like this backwards. It's almost like we should think about those things and try and solve them with like a new
protocol,
sleepy time protocol or something.
Right.
You know, like that's meant to never talk to anybody unless, you know, it's mostly about getting the call up, right? When someone's trying to call you, and starting with a push notification and ending up with I mean, we've had a lot of different FreeSwitch users with that problem. And they do some really crazy stuff. And it kind of puts a burden on us because they're like, I can't have the SIP phone call the other one. I need to have the server to push notification, both of them, and they register, and they both call inbound. But then I want it to feel like it's an inbound to outbound call to the user, except for the SIP's all backwards, and it's not how it's meant to work, but I don't care. Can you fix it for me? So those kinds of things happen a lot.
Oh yeah, mobile. I mean, mobile's crazy, and I mean, your app is killed all the time at random points, and then it has to be able to restart, regain its state. You know, the other element that comes up is pub sub, is that you want to be pushing out present states, other sort of changes, but you run into the same issue. They have to be mediated through a push notification mechanism, and then the client needs to be connecting to the server to retrieve the information. You know, one of the interesting standards things that's happened is HTTP 2.0. And what they added into HTTP 2.0, one of the main things was the ability for the server to push resources to the client so that it was more than just a request response channel. But then Google wrote up this really interesting analysis a couple weeks back where they looked through they did a bunch of data and gathering and analysis to see does it actually improve performance to push things from the server preemptively rather than having the client request it. And a lot of what they found was that it actually makes things worse, especially in the mobile case if you're trying to push things where the client didn't request it, because the client's then not able to track that request as well. It's not able to cache it. It's not able to do a number of other things. And mobile really exemplifies this case where all of the assumptions are around the client making the request and then getting something back. And so VoIP hasn't traditionally done that model, and it's one of the main frustrations whenever you're doing VoIP on mobile. We haven't heard much from you, Chad. What do you work on? What's interesting?
I mean, one comment I'll say, it's a very exciting time for WebRTC. I have a talk, so I won't cover everything I'm going to cover on this, but I think a lot of the excuses for why not to do WebRTC are gradually getting ticked off. And one big one, you know, Microsoft, there's still challenges with, you know, a big IE population, but they're trying to move over the edge. And then you mentioned earlier, we talked a little bit about Safari. They've definitely been the
Hold the mic
laggards.
closer if you would.
All right.
You know, just as a side note, the interesting thing, whenever you're on stage like this and you hear feedback, everyone's natural inclination is to pull the mic further away. But it actually needs to get closer because it helps with the leveling and it helps those guys in the back, makes their life easier.
So, Safari, so Apple finally had actually some specific job openings for WebRTC engineers. And now WebRTC is officially in active development for WebKit, which is the project that builds and goes into Safari. It doesn't seem that the code is slowly making its way in there, but it's not in the it's not usable yet in their nightly type release that they have now for Safari. And who knows when it'll be available. So the big question mark still is Safari in terms of adoption. And I guess depending on your audience or user base, maybe you don't care about that. But the hard part is on mobile, especially if you want to have a mobile browser experience, because Apple basically forces its app vendors to use WebKit, its own rendering engine. You're kind of out of luck, right? You can say, well, I want to use the Chromium engine to do this. Well, you know, in our own browser, they don't let you do that. So you end up having to build a native application for iOS. There's no way around it. Whereas on Android, it's actually pretty easy to, relatively easy today now to build a mobile app, mobile web app.
Bernard, what are your thoughts on that?
Well, I think a couple of things are happening. WebRTC, I think at this point is entering the age where it's possible to build applications that for audio and video that interoperate on all browsers due to the work of FIPO. And I think it's very gratifying to see Anthony get FreeSwitch up and kind of demonstrate that that approach works. Shijin and I talk to a lot of developers, and we try to push them towards that adaptation layer that FIPO talked about, because otherwise we see a lot of code that has branches for each browser. And those developers who do it that way typically complain and say, oh, it's so hard to support Firefox or Edge or Safari, when actually, I think Anthony will testify, it's not that bad, and you end up having less code if you use an adaptation layer. So with that approach, we can typically get people up with simple audio video apps. I think the next stage is to try to tackle some of the more advanced scenarios. And I would love to hear FIPO's opinion on how we would go about providing an adaptation layer for things like simulcast or multi-stream, which I think will be a little trickier because we'll then have the object models to deal with and getting adaptation on that. And when people talked about the spec being finished, I would say I'm now an editor of WebRTC 1.0, and I think we are locking down the spec except for section 5, which is the object model. And there's still a lot of work there because people are still implementing. And until we get some feedback on interoperability, that area of the spec, I think, will still need quite a bit of work. So that's where I think we are. We can do simple things, and hopefully we'll get people writing code the right way. But the advanced scenarios are still out there. In terms of what we're doing on Edge, we just, as Anthony said, shipped H.264 in experimental feature, so you have to enable it in about flags. We're getting to work on the other roadmap items like VP8 and the WebRTC 1.0 API going forward. So we have our roadmap kind of set for the immediate future.
Wonderful, that sounds good. Hey, Shaman, we'll come to you next after we take a question from the audience here. Go ahead, and if you'd introduce yourself and maybe direct your question.
Sure, am I on? Awesome. My name is Chris Klein, and with the final ratification of the WebRTC spec, and knowing that Microsoft is still continuing to innovate on the ORTC spec, above and beyond that, and with the development community obviously wanting to go build robust, very feature-rich cross-platform applications, should we as the development community expect or be concerned about any sort of a fractured experience between the two specs or slight incompatibilities between those two specs?
Yeah, I can talk to that. The first thing to realize is if you read the WebRTC spec, section 5 includes ORTC. So ORTC, the object model, is now in WebRTC 1.0. So when you're talking about final ratification, I think people may be a little bit disconnected because we're talking about a WebRTC 1.0 spec, which now includes objects. And those objects are the same as in ORTC. So objects are everywhere, and I think the main challenge that we see is getting the objects implemented in all the browsers and then shaking down some of the issues, which adaptation may be a solution because the browsers are implementing the objects slightly differently. So that's the challenge we have. I wouldn't worry about fracturing in the spec because I'm one of the editors of both, and we try to make sure the objects are identical and bring things across the same way in ORTC and WebRTC 1.0. So not really a spec issue as much as an implementation issue and perhaps an adaptation problem for folks like FIPO.
Yeah, this is Reynold Jessup. We are in total agreement with Bernard on this. We've got RGB senders and receivers in there in Firefox, and we're working on transceivers. And we'll continue to have the adapter.js and layers like it to cover over any slight differences between things until we can get rid of all of them eventually. But that should help a lot there.
Sounds good. Shamin, did you have any thoughts on this, or maybe you could tell us some of what you were working on? Shamin, can you hear us?
That's me. Yes. So what we're working on, as Bernard summarized already, we're making further progress in the WebRTC support in Edge and also WebRTC API and the VPA as well. And we're thinking about implementing screen capture, other advanced features for RTC services. So while we're making progress, we want to make sure we have a good interop. So we're working with Mozilla and the Google folks as well. And in the future, hopefully, once we make enough progress in the video interrupt area, you guys don't need to run the video transcoding all the time.
Sounds good. Do we have other questions from the audience? We have a question back there. Go ahead if you'd introduce yourself and ask your question.
Hey, this is Amit. We have been trying a lot of SDKs for mobile WebRTC based applications, and we have developed them. Mostly the simpler scenarios are working, but when the user count is going on 3, 4, 5, we are seeing a lot of variances. Devices getting overheated, abruptly people are getting out of the call. So we are seeing simpler scenarios working, but with lot many people coming into the same call, the APIs are or the SDKs are failing in showing the same performance.
Who wants to take that?
I can. That happens a lot. There's two tracks of development when it comes to WebRTC, and that's kind of one of the reasons that we started trying to do a different one, because we work on the MCU model, and that's basically one video stream per caller, and we don't knock the other ways of doing it because there's benefits to those too. But if you take our team and our software and what we were capable of, it was a better direction for us and a quicker win to implement the way we did. Because you'll find that people on mobile devices, if you're trying to have a conference like this where you've got like 5 people in the conference, that can like overheat your computer or use up all your battery. So those are some of the things that are challenged. You know, we're already talking about Apple like trying to turn off the device as often as possible. That's probably crying it when we're on a video conference with it because it can't, and it's stuck. It's probably just draining the battery at full speed. So that's one of the reasons that we wanted to do a one-stream model. And we were thinking of, we have some ideas to kind of simulate the SFU kind of thing, like the things that people like about it without all the streams, so that you can do both ways. I think if you're in an environment where you know there's lots of connection speed and whatnot, there's not so much of a problem. But I think even all of us who make media engines need to work together more on the, say, like how to handle packet loss and whatnot, because video and packet loss don't go together as quite as easily as audio does. It's harder to come back from it and those kinds of things. And I think that we've tried to do some things with our jitter buffering and whatnot, and I'm not so sure how the rest of them all react. It's a lot of work just to test that, because you're kind of happy that it works, and then you're like, now I want it to work with 10% packet loss. You know, it's like, it's already hard enough to stream the video, and now you want me to lose 10% of the packets and have it work still. I mean, and Opus has done that for audio, and there's going to be efforts to do it in video too. They're just not here yet. So, I mean, between those things, we had some ideas where maybe we would do kind of a weird idea. We might actually work on this in the upcoming year. I don't know if we'll get time to it or not, but I really wanted to try something where we basically send the MCU as a film strip. Like, so right now we're generating the canvas remotely over in the server, and we're sending a single picture. And then we have flexible canvas sizes, so we can change it around. Like, we could easily like flip this to be like a different 6x6 grid, or have only one of the people foreground, and that gives you kind of an ability to do something like more like a TV show kind of thing, where you could like focus on who's talking. And we have voice following the speaker mode, or we can turn that off, or we can make a layout where there's one really big frame and everyone else is little, and whoever talks goes in the big one, and those kinds of things. But it's kind of another idea. I wanted to be able to like send all the video streams basically just on top of each other in a big film strip, and then don't just render it, but hide it in the background, and then use some of the GL stuff that's in the web browsers now to generate the the video wherever you want. So, because the only big thing about SFU that people seem to really care about is this thing where you can click on who you want to see or whatever. And I want to make this guy bigger because his shirt's cool or something. I want to see it. So they click on it and then he's bigger. So there's some idea we have like that, but with the long-term thing, like the holy grail for all this is if you get all that object model WebRTC working, FreeSwitch is in a position to do some crazy things like accept all the video streams from all these legacy devices, and then rather than being forced to see the canvas, this one canvas that we put, we can take another level of indirection against that and using API calls and whatnot, request, go tell the server, I want just Robin and Bernard side by side. Like, even though all these people are in here, like, generate me a canvas that contains those two people and send it to me. And then you can create as many of them as you want and place them on the screen and, have like all these different streams coming over one ICE connection. And like all these things are kind of on a wish lists for who knows how many years it will take, or maybe never. We'll change our mind along the way. But that seems to be like the hybrid super MCU SFU thing. So then if you're in that, then you get all the features at once, and you can only have one stream to the browser sometimes. Like when you're in a mobile app that can't afford to make like 17 connections. And keeping one video stream up is sometimes hard over LTE. And imagine trying to do like 5 at once to all the other people in the conference. So then it can fall back. Like I don't have enough bandwidth for all the super cool features, so just send me a kind of canvas of every single, like this. And then maybe something that's got endless bandwidth or on a desktop somewhere can do more fancier things. And you can kind of get the best of both worlds. But that's like an insane amount of work away still. But
well, we could add even more work to that pile and make it even fancier, where when the person clicks on it, it requests to the server to send me more of that video stream, so that there's some interaction there.
Yeah,
that's a traditional SFU sort of thing to do. That's what video does, and other people like that. One thing that's underway at the IETF right now in being specified, and we're going to be starting to work on preliminary implementations of it so we can prove out that it works in practice, is a privacy maintaining SFU design called PERC, which would allow for people in a conference to for you to implement an SFU that does selective forwarding, but where the server itself can never actually decode the video streams. They remain encrypted against the server. The RTCP is not encrypted against the server, but the actual video streams themselves are, and they get forwarded to the other participants in the conference. So this allows for a more secure conference. That's one of the many things that are currently underway. Some of the things that Anthony mentioned are definitely workable. Some of the taking all your videos and instead of doing all the compositing at the server, just composite them into a simple, as he put it, film strip with all the images one after another, and let the client side composite them however is appropriate for its interface. You could show just one of them. You could show one large and a bunch small, etc. With OpenGL and other things like that, that isn't necessarily even that expensive power-wise on a modern smartphone. So that's possible. You are spending bits for all those things, even if you're not showing them, and that's a minus. And there's of course always the issue of bandwidth adaptation when you're sending these video streams down to clients. Your desktop clients may have 50 megabits available to them. Your mobile clients may have a half a megabit, 1 megabit, 3 megabits, and you may need to encode in multiple resolutions and multiple bit rates to handle that. So there's a lot of stuff to be done there.
Yeah, and luckily no one's asked us for a 4K video stream yet over WebRTC.
When the re-encoding goes challenges that model of doing the encoding on the client and the cryptography on the client as well, so that the server can't see it. Because if the server can't see the stream, then you can't have a server in the middle that's doing multiple re-encodings. So how do you deal with that issue other than pushing the multiple encodings down to the client?
Well, that's where things like simulcast come into play, where you actually are doing multiple encodings at the client side and providing the server with, and that's what SFUs typically do this. You have the client encode in either a layered encoding, like H.264 SVC, or in a simulcast type, where you make separate streams at different resolutions, and you feed those up to the SFU. The SFU does a selective forward of the stream. For each recipient, it forwards just the stream that is appropriate for the bandwidth available on the connection that person is. So if they've got shitty bandwidth, you send them the QSIF 160, the QSIF video. If they've got tons of bandwidth, you send them 720p, etc. That's bread and butter for an SFU.
Well, the challenge, I think, comes in where the sender is also bandwidth limited, where you're sending from one mobile device to another.
If you don't have the bandwidth to send it, well, no one's going to get the high resolution.
No one's going to get the high resolution.
No matter what you do.
Right. Do we have any other questions?
I think there are some.
Oh, go ahead.
Yeah, I just wanted to comment on the SFU scenarios. One thing that we've seen historically is that, at least to date, SFUs have typically been developed along with clients. That's how the video industry is developed. So people develop their client and their SFU to work together. I think the challenge here is to get SFUs that work with a lot of different browsers and to understand how that would work. I mean, Anthony has described the MCU model, which does work well because essentially it just provides one stream. And that's kind of where we are today, where everyone should be able to render that stream. But in the SFU model, you're now requiring browsers to interoperate with simulcast and with multi-stream, and we're still not quite there yet. And on the SFU side, it's, the behavior may differ, because we see there are some browsers that can handle reception of simulcast, multiple stream, and putting it together, some that can't. And so I think we still have a little bit of work to do, particularly in the testing area, which Fippo may have something to say about how we could test interoperability of simulcast in some of these advanced scenarios. We're definitely not there yet.
With regard to testing, are there any automated test interoperability test frameworks that have come up for sort of doing cross-fold validation of all of the sort of scenarios that are here?
I can talk about that. So a while back, Bernard contacted me as part of the INTC, which is an organization consisting of people like Polycom, Microsoft, and others, Video, for example. And they were interested in doing interop testing between the browsers as a first step. Because the current state of interop testing between browsers is some tests written by the Chrome team, where they test their WebRTC sample with Chrome and Firefox. And that is very limited because WebRTC is a one-on-one chat application, so they only send a single audio and video stream to the other peer. They don't do complex things like renegotiations, so those things are basically untested in interop. And what Bernard asked was basically, we have some tests for Adapter, which tests using Selenium, which is a tool to automate browsers and basically click buttons, execute JavaScript at times. And based on that, I wrote some test beds, a number of interop tests, which basically test interop between different browsers, start different browsers, make sure video is sent from one to the other, make sure that the ICE connections are up and stuff like that. And it's a step in the right direction, but it's a long way to go.
Testing is always the hard part. Do we have any other questions from the audience here? We have one in the front.
I just had a quick question. Anthony mentioned earlier that you were putting the SDP into the core of FreeSwitch with WebRTC. Did I mishear you?
No, that's true.
Okay. Do you want to expand, or just that the core is now going to handle all that renegotiation and all that stuff through SDP?
Well, basically, we have Modverto, which is our WebRTC endpoint, and it is using the same STP engine that the SIP module uses. So the WebRTC works through SIP, either standard, any of the transports that SIP supports, so it can be over WebSocket, UDP, or TCP, because the STP defines the entire thing. And then Modverto is also using the exact same code from the core now. It used to live over in the Sophia module because it was the only thing that needed an STP, but now there's actually any WebRTC stuff can do it, which maybe the days are numbered on that too, but luckily we have the adapter.js to translate it back to it because I think they're trying to move away from it. But that's like the most comparable interface to what we have, so we can maintain like SIP and it's not going away anytime soon, at least. So maybe someday we'll have multiple ways to negotiate media, but right now our STP engine is fully capable of doing any of the, because WebRTC media is really like a collection of standards more than like one thing. It's kind of a bunch of stuff that's been around for a really long time that kind of just got shoved together and makes one kind of entity. So as we add each of those little pieces, we added it to our media engine. So now we basically just, if we want to make another module tomorrow that just uses some made up signaling protocol, we can use the same media engine code without having to re-implement that in the modules.
Is it removed from Sophia?
Yes.
Okay, thank you.
The question was whether it was removed from Sophia.
It was removed in 1.4. And it's got more of it pulled in as time went. So yeah, in 1.4 we moved all of it and added audio support. In 1.6 we added video also. And I think I see someone asking.
We have a question at the far end of the room over there.
Hang on, let me
just
get
hold on a moment. We'll get a mic to you.
Mic to you, so it's on the.
How are we doing on time? Did we have this for an hour or hour and a half?
About
hour and a half.
minutes.
Okay.
Previously, Robin stated about problems with mobile implementation of SIP. Did you mean the native SIP stack on Android? And if not, if there's a third-party SIP stack like BJ-SIP, could you state specifically what are the specific problems, like main problems that can lead to breakdowns with new releases from iOS or Android? What are those risks?
I was talking about more from a user experience, and it was actually expanded upon a bit later. I forgot who expanded upon it, sorry. But the problems really come down to the fact that SIP does expect a continuous connected scenario, meaning that for a mobile app, as mentioned before, the mobile app goes in the background, it's killed, you no longer have a stable connection. If a SIP invite comes in and your app isn't running, you have to park that SIP invite to get your app booted and then do a command-driven interface where you've got the SIP command coming in and then you respond to it once your app's booted. So you need to use some kind of proxy in between server, like a Camellia thing that allows you to hang your SIP off and understands things like push, which is an ideal user experience. And then when you start moving into other future scenarios where you're trying to do Wi-Fi LTE handoff or trying to take advantage of any of the newer object models, you're going to even see further breakdown where SIP really doesn't fit in that model. So you end up in a situation where you're arm wrestling with SIP to get it to do what you needed to do rather than just concentrating on building your application. So I'm not saying remove SIP from your infrastructure entirely. I'm just recommending using just straight up WebRTC, using your own interface to your server, and then from there, potentially, if you want to use SIP, then go ahead. But at least from that infrastructure standpoint, where you're trying to deal with push notifications, your application backgrounding and foregrounding constantly, trying to take advantage of more advanced scenarios where you're going to have to deal with in mobile, do your own API however you feel it's best to handle your user scenarios, and then have whatever you want on the back end to do your protocol stuff. That's just my perspective. You want me to expand further, I'd be happy to, but I don't want to occupy, hours of time on this subject.
Yeah, I'd like to second what Robin said. We have both Skype and Skype for Business. Skype for Business is more SIP oriented. Skype is not. And we've seen the challenges that Robin said in the SIP environment when we do our mobile apps. The other thing I think it's been touched upon is the challenges with ICE. when you're constantly being backgrounded, you need to be able to bring up a connection right away if you come to the foreground. And I think Robin might comment. At the IETF meeting, we had a discussion of a lot of interesting extensions to ICE, including things like continuous nomination or use of relays to bring up connections. So I think you've pretty much got to do some of the innovative things that were showcased in Android's Duo to bring the connections up right away. And that's a little bit of a challenge within the RFC 5245 model, but perhaps not with trickle ice and some of the new things people are talking about.
And you know, trickle ice is now supported, I believe, by all the browsers.
Well, actually, we don't support it in Edge yet. But
okay, well, almost all the browsers. You will soon, I'm sure.
I hope so.
We're actually, Firefox is actually planning to be working on implementing continuous nomination in later on this year. So we'll be working on some of these issues as well. But yeah, the things that Robin said are absolutely and Bernard said are absolutely true. You know, the SIP model just does not play well with mobile, and so it's best to find other things, other ways to work around that. One thing I was going to mention earlier, and I forgot to mention, is we're also implementing proper RFC DTMF support in Firefox. There's a workaround you can do with web audio to do in-band DTMF. It's a little ugly and doesn't always work. And some gateways would far prefer it not in-band. So we'll be working on that in the near term as well.
Good luck with that.
I would just like to expand on one point that's about SIP, just from a mechanism that why it doesn't work in general. And that's because it's very much, when it has a stable connection to you, it's expecting to be able to deliver command on demand. So if you have a message coming in, it sends you a message command. If you have an invite coming in, you have an invite command. And if you're in a constantly connected and disconnected environment, the SIP protocol just fundamentally doesn't work. You need much more of a, I'm connected, let's synchronize what our last state was, get us up to the current state, and then continue. And it's a fundamentally different model. That's why if you're doing it in your back end, it's fine, but bringing it to your mobile just doesn't really work that well.
Other questions from the audience? Who's doing anything interesting in the audience here with WebRTC? Raise your hand. Anyone doing something interesting with WebRTC? Okay, we got one there. Anyone else? Really? No Web. Okay, we got two over there. Let's talk to you. Let's get a mic over to him, and he could tell us what the interesting thing he's doing with WebRTC. Either one of them.
So everybody's talking about how SIP doesn't work all that well for WebRTC, and at OnSIP we build SIP.js, which is a SIP JavaScript signaling library for use in building WebRTC endpoints with SIP. But I totally acknowledge that there are certainly complications with mobile and SIP, for connectivity reasons and having to be able to bring things up quickly. And I know that a lot of people do use things like push notifications in combination with SIP in web apps on mobile. So I just thought, it's something that we do. We're heavily invested in SIP, and I think the technology has challenges for sure, but it does work for us.
What's been your experience with it, and how are people using that on mobile?
It's very much what people have described here, and that in environments that have connectivity problems, or if you're moving between networks a lot, there can be issues. The simplest solution is to keep a low registration interval so that your connection is refreshed fairly quickly for a simple sort of solution. But in general, it works fairly well based on our experience. We don't do a lot of mobile development. Again, we're basically the library maintainers. We don't actually do a lot of application implementation. I do know that there are people who are building things with SIP.js on mobile for both iOS and Android. And I think they do make use of push notifications in combination with it.
Are they building browser-based apps, or are they building native applications
building-
using React Native or something like that?
They're building, generally speaking, native applications using Android WebView or Cordova with iOS.
Very interesting. Other WebRTC projects that people have ongoing. What about his? Let's talk about his.
Hang on, let me get a mic
Hold on,
over
we'll
there.
get a mic over to you.
And later I'll chastise Travis for having him bounce back and
Running
forth across
you
the room.
around the room. We're
We're gonna have
this
to
is
get
our
a throwable
fitness
microphone.
This is our fitness activity. This is the fitness portion of our program. Go ahead.
So yeah, we deployed FreeSwitch in Amazon FreeSwitch platform, and Node.js as a front end to it, and then we built API to the whole platform, and using WebRTC from Chrome and Firefox where it works. And the first application we built is a Slack add-on where these issues, we're not using inbound SIP, we just send invites through messaging. And this way, if you're in Slack, if you know what Slack is, it's basically a team chat tool. And so you see 5 people sitting in chatting, and then all of a sudden decide to switch to voice because they have complex concept to discuss and they need voice. And so we implemented the Slack add-on where suddenly if you're on a desktop or laptop, all of the people immediately get into a conference, high definition conference, and also support it on mobile platforms, iOS, as well as Android using PJ SIP stack. We tried Cordova on Android. It kind of works. And the problem with the browser, it also works on Chrome on the browser, but the problem is that on the Chrome browser, when the screen turns off, then the audio connection gets dropped, okay? And that is a bug that Chrome team recognized, but more than a year ago, I haven't fixed it. And so we tried with the browser first on Android, and then it didn't work with the screen turn off, and then we went to Cordova. That kind of worked, but not really clear how to do it on iOS, not really stable and straightforward, so we went to the native implementation with PJ SIP, and that seems to work very well. So that's what we did.
Very interesting. Let's go around our panel and just touch on how we've seen things being used with WebRTC, and also what sort of projects, what sort of uses of WebRTC do the people on the panel here want to see, and what sort of projects do we think that people should be interested in doing that are possible now because of these new standards and the new things that have gone into the browsers that maybe were not possible a year ago. So maybe Anthony, if you want to start with big ideas, and then we'll make our way around.
I just had a new idea while we were up here that maybe we can come up with some kind of socket hibernation, where the other side keeps it open even though it can't find it. And I already know there's some like crazy solution in SIP where you use like cookies instead or something so that you can reestablish a connection to a socket, because that way you could be asleep and not lose you could reestablish, since really internet connections aren't actually like wires that you have to cut, it's just a timeout. So maybe we could make in SIP sensitive, transport agnostic. You could send SIP over email.
No, that'd be a good abstraction, and then that could tie in with some sort of push system so that when it's actually trying to send down the socket, it first triggers a push notification to go out and then blocks and waits for that socket to maybe be reestablished. Or maybe the guy's on an airplane and it's going to take an hour and a half for that connection to be reestablished.
Or if we could get everyone to agree on the same push format, you could actually put the data in the notification.
Right. There's semantic problems with pushes that about their delivery and confirmation. But do we have a comment up there?
Yeah, at the last ITF meeting, there was a lot of excitement around QUIC. The first work there is going to be HTTP over QUIC, but it's occurred to me that this might end up influencing WebRTC because that's one of the scenarios that QUIC is made for, is very expeditiously creating a new connection, basically zero RTT. So I'm wondering if anybody would like to comment on that. The first is probably signaling, but it's also been discussed for other WebRTC uses conceivably.
No, at Silent Circle, we considered very strongly using QUIC for that very reason, for rapidly establishing a connection after a push notification came in. So I think that's definitely the direction that protocol is going to go, is into this mobile space where you get the push notification and you want to rapidly reestablish your context with the server. I think it's a great use for it. Other thoughts on QUIC?
I've been following it idly for a while and was watching what was going on at the IETF as well. And I think there's a lot of potential for QUIC. And be interesting to see what the right way to integrate that with WebRTC is, because there are several ways you could approach it. But more than happy to work with anyone on that.
From an app and operating system inside mobile perspective, majority of vendors, such as majority of OS owners, right? So Apple for iOS and Google for Android, do have socket offloading mechanisms. So instead of your app holding the socket, you actually establish the connection, then offload the socket to the operating system, and your app can actually go away. That mechanism allows you, or allows the app to stay responsive even when the app is actually not in memory or running. So any communication going over that socket, in Windows it's called Socket Broker. It has another name on Android and iOS. The app is reinstantiated, so you don't have to sort of quote unquote hibernate the socket. That sort of is already solved with the operating system. But there are other challenges, as Bernard has noted.
Yeah, I mean, the trouble with that is that at least the APIs I'm familiar don't handle network changes. So if you change networks and now that socket is no longer valid because you've gone from Wi-Fi to LTE, that socket actually does need to be reestablished, and the operating system's not going to reconnect that for you.
Well, it's not going to reconnect, but it does notify you the fact that socket was interrupted, and then you make your own decisions of what to do next. So in the case of Windows, for example, when you establish a socket connection, let's assume that it's a traditional socket, not SSL, not HTTP. When you establish the socket is in sort of quote unquote the hibernated state. It doesn't know when it disconnects, but the moment it does disconnect, the operating system wakes up the background process of a Windows app and gives it a failure reason. So for example, disconnected, or data sent or closed by destination, or by remote host, right, in this case. And you can make your own decision. You could choose to reconnect, or you could choose to say, oh, the phone has switched from cell to Wi-Fi, therefore I will connect in a different way. So there's lots of reasons, but the operating system does let you know that happened.
Yeah, I mean, our experience with that in the field has been that doesn't solve the problem, because let's say that you're switching from LTE to a Wi-Fi network, that you get that notification, the Wi-Fi network is up, but you actually can't make a connection yet at that point. Maybe the user has to go click through some web portal, or maybe it's just the user is not quite in range of that Wi-Fi access point yet. And so at the point that your app is awake, you're not able to reestablish that connection. And then you get killed off and you don't get a new notification, and now you're essentially dead in the water until you get a push notification coming in that prompts you to go and try and reestablish a connection.
Yeah, I think you touched on a very critical element of this, right? That it's not just that notification that should give you an idea of what decision to make. It's network quality, it's available networks, right? You may have very low Wi-Fi, but you may have great Bluetooth connection. Not saying that you're going to do WebRTC over Bluetooth, but you can enumerate networks and find out what the most preferred network is.
Yeah, I think Robin Robin may also want to comment on this, but the scenario you just described where you change networks, you've got a real problem potentially, because now you have to allocate new turn candidates, relay candidates, and kind of go through the whole ICE process. There is a nice little spec in the ICE working group called turn mobility, which essentially allows you to reuse the turn candidates. And I guess Robin has implemented that in ORTC Live. And I don't know if you can talk about it, Robin, but I think that does help you come up much more quickly.
So there's a bunch of issues here. You're right, Bernard, and there's a bunch of issues here. And when it comes to TCP, there are solutions, as Max was saying. They're not great for several reasons. One also is the TCP timeouts can be long, even if your operating system may not detect that there's actually a problem if there's actually something more fundamental going on. So you can have long timeouts. I'm really excited about Quick Protocol and being able to, support what multipath TCP was supposed to be, and it really seems much more promising. I'm hoping the operating system vendors will bring that right down into the OS and give you exactly what Max was describing, except via Quick, so they can support multipath and keep multiple paths alive. And in terms of being able to quickly get your connection going again, one of the problems is that your IP address set can completely change, your signaling connection can completely be gone, and you have to be able to reestablish things quickly. Something like your turn mobility, where you get a stable IP and a stable port on the server that is always alive to you, and you basically swap in the background your connection between your mobile app to your turn server from switching from your Wi-Fi to LTE, and that IP address can completely change, but your turn does not. That allows you to basically have the remote party understand that there's a stable IP and port that you can always go back to and reconnect. I still think that there's a little bit of work to be done on the signaling side to support that properly, but it is a great step forward and it does help with stability. So there's still innovation to be done here, and that's what we're doing in the ORTC Lib, is to bring all these techs to the forefront as quickly as possible.
Good. Other thoughts on that from the panel? Any questions?
Well, turn mobility.
Go ahead.
Turn mobility is actually supported now in some of the open source turn servers. So it is something that people can play with.
Yeah, CoTurn supports it now.
Interesting. All right, so everyone in the audience should give that a try. Do we have any other questions that have come up based on this recent discussion? Questions from the audience? Okay, going back to the panel, do we have people on the panel here, do we have any thoughts about what is possible now with WebRTC that wasn't possible a year ago, and what sort of applications can people build off that? Do you have any thoughts on it, Chad?
Well, I was going to say, for WebRTC Hacks, I like to write about futuristic applications, and I get really excited about things like augmented reality, virtual reality type applications. I think we're a little ways from that. Some of the things that are happening with the video specs, I think, will help enable some of that and more complex video scenarios that come into play. But for my day job, I deal with click to call. Like, I think it was the most basic common use case. How often do you see a phone number on a website, you just want to be able to click it and dial right there, and you can't do it. So we're still a long way from that. From click to call, it's mostly just an implementation thing. But I think we should be careful. There's a broad range of what you can do. There's still a lot to be done. Yeah, so I do click to call day to day, but I'd prefer to see some robotics, machine interaction, that sort of thing, computer vision.
Very good. Seven, what are you building with it? Do you have any thoughts about cool things that can be done?
With WebRTC?
With WebRTC?
No, but actually,
this is a creativity test. This is what I'm doing to the panel.
I read some, but I had some bad experience working on WebRTC. When I making VP8 and VP9 protocol, they have specs. But when I rate them, to send the video data to So WebRTC, we need to cut down the stream to smaller chunk and send out. And they have a spec and said that we should follow, but it doesn't work. It really doesn't follow that. That's spec. But finally, we figured out that, and now they follow that spec, and we made that work. I know. Okay, so we just want try hard to make it work better and stable, but really we don't know what to do with that.
Got it. All right, up on the video wall here, do any of you folks have thoughts about? We've got a room full of developers, a room full of business people looking for new ideas. What should they be thinking about doing with WebRTC?
Well, I think
Maybe we got a bunch of people here who want to respond to that. So
go please, go ahead.
Yeah, well, maybe I'll start first. In part of my day job, I work with Skype, and we've announced that we will make plug-in free Skype available on multiple browsers. So that's something I certainly hope it's going to be possible over the next year. We've gotten we shipped plug-in free Skype on Edge, audio and video. We're working on other browsers, initially audio and then video. With the work on adaptive.js, I think it's possible to deliver basic audio and video functionality. It's a little tricky to do it at scale because we're still not quite there in the statistics and operational metrics, which is something we haven't really touched on in this panel. But when you're operating, with millions of users, that's very, very important. And so that's something I'm probably going to be spending a lot of time on is, updating the statistics spec, trying to get some of the more advanced metrics in there, and basically being able to operate these services at scale. And then kind of moving beyond that, I think screen sharing is something we'll see in the next year become very widely available. We're certainly working on it in Edge with the new W3 screen capture spec. And once you combine all these things, you should be able to have very nice conferencing. Beyond that, we have the advanced video features. But I think maybe in the next year, getting things working at scale, getting them interoperable, adding the screen sharing, and perhaps a media recorder would be a pretty big first step.
Perfect. Robin, it sounded like you had something to add there.
Well, I wanted to mention that I'm really excited about not just the mobile space. I'm also excited about what we're going to see in the IoT space because these devices are getting very powerful. With you're seeing Windows 10 being able to run on these IoT devices, which is absolutely incredible. So I don't know, I don't know what's going to happen there, but I'd love to see something in that space coming down the pipe in the future. I've also got, in my lap here, I've got an Xbox One. I'd like to take the WebRTC lib and make it run on this particular platform as well. I think it's with the new stuff that we've got from Microsoft, we should be able to bring it to that platform. So I'd love to see that going on as well. And hopefully seeing, some expansion of where we're going to see not just the mobile traditional, talking head scenarios where we've got, a desktop and a mobile app, but bringing in all these different devices, your console plays as well as your IoT plays. So I'm really excited for what the future is going to be in this area.
Yeah, one thing I want to add here is, we have the H.264 video support, even though as experimental feature. But as we're seeing today, Switch folks put it into the video conference call already. So we would really encourage people to try it while we're making further progress, and we'd like to get feedback. So before we turn this on by default, we want to make sure it works for everyone.
I think that tooling is also important. I think Max can also speak to that.
Max, do you have any thoughts there?
The one thing that the one thing that we realized as we were getting deeper into WebRTC is there is a notion of perceived quality versus real quality, right? So you can do all kinds of censoring on the server side to understand what is being sent up, but in reality, you're only judging with what you receive, right? So we actually built some very interesting tool sets that can run directly within Visual Studio, and sort of echoing Robin's comment on potentially doing this cross-platform with Xamarin. It's very exciting. So today, if anyone is familiar with the Visual Studio performance analysis tooling, we're going to be releasing a version of performance analysis for WebRTC. It will include all the standard Google counters. In addition, you will also see a number of system counters that will tell you how good the video is. And that is sort of the some of the most important indicators. Are you receiving, for you to judge why, right? Why is video not good? Is it because of memory, CPU? Is it because you're not receiving enough? It's a very exciting area, and we're very excited to contribute.
That sounds excellent.
Some other things that have occurred in the last, you're asking about the last year or so. One thing is that support for web audio plus WebRTC has improved. Firefox has had that for a while, and Chrome had it for a while, but we each had it on different sides of the equation, send or receive. And both now supported for send and receive for modifying the streams, WebRTC streams with web audio. So that's something you can play with. Another thing where there's a lot of opportunity to do interesting stuff with that hasn't been discussed here is data channels in WebRTC, which allows you to have lots of any number of either TCP-like or UDP-like or somewhere in between with partial reliability data transfers in parallel with the audio and video. And that can allow for certain types of real-time applications that might be painful to do otherwise or require lots of additional connections and other stuff like that. So if anyone has questions about data channels, feel free to ask me.
Or find him in the back. With that, I think we're going to wrap up. Big round of applause for our panel, for our remote participants.